look at another one. Let's solve 4x squared is equal to 9. My first step is to put it in standard form. So I need to add a negative 9 to both sides. So we can get 4x squared minus 9 is equal to 0 when I add a negative 9 to both sides. A negative 9 added to 4x squared gives 4x squared minus 9. A negative 9 added to a positive 9 gives 0. So I added a negative 9 to both sides. Once I get it in standard form, I need to factor. I can factor this by the difference of two squares. The square root of 4x squared is 2x. The square root of 9 is 3. So it will be 2x plus 3 times 2x minus 3. So I have 2x plus 3 is equal to 0, or 2x minus 3 is equal to 0 when I set each factor equal to 0. This gives me 2x is equal to a negative 3 when I add a negative 3 to both sides, or x is equal to a negative 3/2 when I divide both sides by 2. For this one, I get 2x is equal to a positive 3 when I add 3 to both sides, or I get x is equal to 3/2 when I divide both sides by 2. So I get x is a negative 3/2, or x is a positive 3/2. Now sometimes you'll see this written as x is equal to plus or minus 3/2. So the plus or minus takes the place of both of those answers. X is a negative 3/2, or x is a positive 3/2. Now let's consider the general case. Based on the last problem I did, but the general case. Let's look at x squared is equal to k. I have something squared is equal to a constant. I can put it in a standard form by subtracting k from both sides to get x squared minus k is equal to 0. Now I can pretend that k is a perfect square and factor it as the difference of two squares. The square root of x squared is x, and I'll write the square root of k using the radical notation. So it would be x minus the square root of k times x plus the square root of k equals 0. So I simply factored x squared minus k by using the difference of two squares and using the radical notation to denote the square root of k. Now I'm going to set each factor equal to 0, so I get x minus the square root of k is equal to 0, or x plus the square root of k is equal to 0. Now I need to add, for this one, the square root of k to both sides to get x is equal to the square root of k. Here I add a negative square root of k to both sides to get x is equal to a negative square root of k. I can put them together to get x is equal to plus or minus the square root of k. So I did exactly the same thing I did with the last example, but in this case I'm using a letter which gives me a general formula or general way of doing it. And here comes the way of solving certain quadratic equations by the principal root method, or by taking the square root of both sides. If x squared is equal to k, then x is equal to plus or minus the square root of k, where k is a constant. So if I have x squared is equal to something, then x is plus or minus the square root of that something, where the something is a constant. So let's use the theorem now. The fact, and notice I put a star beside it. This is something you need to put on your study sheet. Now let's use that to solve a quadratic equation. Let's solve 2x squared is equal to 5. Now I know I can use my principal root method to solve it because there is no linear term. In fact, I'm going to write a note down here, then come back and solve it. Note, one can use the principal root method to solve quadratic equations when there is no linear term. Now, of course, linear means x raised to the first power. Now, if you go back up and look, I have no linear term. I have x raised to the second power, and I have a constant. There is no linear term. So what I want to do with the principal root method is to get x squared by itself, and then take the square root of both sides. So I can divide both sides by 2. To get x squared is 5/2. So I simply divided both sides by 2. Now I have x squared is a constant. So I'm going to take the square root of both sides, but I've got to remember that it's going to be plus or minus the square root of the constant. So don't leave off the plus or minus. I've got to, if I have x squared is equal to a constant, then x is plus or minus the square root of that constant. That's just what I proved for you. So I have x squared is a constant. So x is going to be plus or minus the square root of that constant. So x is going to be plus or minus the square root of 5/2. Or I get x is plus or minus the square root of 5 over the square root of 2. Rationalize the denominator by multiplying by the square root of 2 over the square root of 2. And I get x is plus or minus the square root of 10 over the square root of 4. Or I get x is plus or minus the square root of 10 over 2. Now I can write that as x is equal to the square root of 10 over 2, or x is equal to the opposite of the square root of 10 over 2. So what plus or minus means is either the positive or the negative. Now with square roots, I want you to approximate the answer and write it to the nearest hundredth. So pull out your calculator and let's approximate that and get to the nearest 100th. So we have the square root of 10 divided by 2. So I need to do the square root of 10 divided by 2. And then I'm going to hit enter. And I get 1.58 when I round to hundredths. So I need to round that to hundredths. 1.58. Since that's less than 5, I round to hundredths. 1.58. So I can get that x is equal to, or x is approximately 1.58, or x is approximately negative 1.58. We can use the same principle to solve literal equations.